questions and feedback, things like that. And whenever you're ready and you start, I will start the timer. And that will just be so if you go over 10 minutes, we'll give you some sort of signal that you need to think about wrapping it up.
Okay.
But other than that, don't worry too much about the time. Okay, so whenever you are ready, you may start.
Okay. Hello, my name is Emily Falk, and welcome to my 2010-2011 Math and Science presentation. What is the effect of center of gravity centimeters from nose on 5 times seconds of a paper or plane? Center of gravity is where all of the weight of a paper or of a plane passes through, and weight is really just force acting on a certain object due to gravity. Force is just a push or pull. Planes have 4 forces of flight to help them fly. One is lift, and is created by Bernoulli's principle, which means that as an object moves through a liquid, it creates an area of high pressure beneath the wing and low pressure above the wing. Gravity is just weight that's pulling the plane down and must be counterbalanced by lift. Thrust is created by planes, usually planes' engines or propellers, and propels the plane forward at a certain speed, which is called velocity. And drag is created by the plane moving through a liquid, which is just air, and it creates friction, which is called liquid friction. Control surfaces on the plane's wings control their yaw, which is a left to right motion of the plane's nose, and then pitch, which is an up and down motion, and then roll, which is turning the plane in a circular motion. In this experiment, control surfaces called ailerons were put on the paper plane, which is a model plane, to test the 2 variables relationship to control its pitch, because there was a problem with the plane automatically diving after being launched. To test the 2 variables relationship, a hypothesis was used. As the center of gravity increases, the fly time will also increase. After performing the experiment, raw data was collected for each of the center of gravity variations. The center of gravity variations were in 3 centimeter increments away from the nose. So there were 0 centimeters, 3, 6, 9, and 12 centimeters. The variations were used because to test the center of gravities on the flight time of paper airplane, and so it was used by a paper air clip moving in 3 centimeter increments to change the weight of the plane and to change its concentration in a certain way. The center of gravity was found by attaching a ribbon to the paper clips or paper plane's ridge and then finding the balance point. So this means that the paper clips at say 6 centimeters would not be the center of gravity. Instead, it would be a different location. This is a summary statistics table which has all measures of center and then some measures of variation of other measures. They have the center of gravity variations on one side, and then has all of the raw data, which there was 10 trials for each of the center of variations, calculated into certain modes or means or medians and other things like that. This is a bivariate table, which means it has 2 variables. And has the mean flight time, which means that the mean was taken from this column here and then put it to the mean flight times down here. This is the center of gravity on the left side. The mean flight times were plotted onto the scatter plot in these little spots, and then adding all of the mean flight times dividing by 5 would get you this little box, which was also used for center of gravity, which was adding up and dividing by 5 to plot this little box and to draw the slope through, which is the line of best fit, to show the trend of the data. After finding the slope, it was negative 0.11. This means that as center of gravity increases by 1 centimeter, the flight time the plane will fly will be decreased by negative 0.11 seconds. And if the center of gravity is at 0, the plane will fly an average of 2.3 seconds. This is a univariate graph, which means it has one variable. Its flight time, and it was used to show the raw data's frequency in certain bins. So the raw data was grouped into approximately 1 second increments, and then shown the variation or the frequency there were in that raw data variation of the center of gravity. So the center of gravity is increasing here, and then the flight time, the frequencies of the flight time is spreading out and decreasing. Using this, it is concluded that the hypothesis was rejected. This means that the center of gravity was increasing, but the flight time was decreasing. The mean was used to show this data because it had no outliers and was following the negative trend of the data. Some sources for error in this experiment were the launcher. There was a launcher to use to regulate the flight or the speed that the plane was launched. The launcher was made out of a meter stick and then 2 rulers and some rubber bands, and then the paper plane was attached with a clip and then pulled back to 40 centimeters, then launched. The paper plane didn't fly off, instead it just fell to the side, making our flight times inaccurate because the plane wasn't actually flying. So the launcher was used for 2 trials of all of the center of gravity variations, and then it was switched to hand throwing. The hand throwing worked much better, but hand throwing could have been just making the plane, using the momentum that we were throwing it at, could have just made the plane fly instead of using its wings. Dew was seen on the first hour of the experiment, and when the plane landed on the grass, it could have soaked up some of the water and changed its weight, making the paper clip that we used to regulate the paper plane's weight ineffective. There was some wind also in the second hour, and wind creates an area of low pressure, or the amount of force on a certain area, making the plane just glide instead of having to use its wings and create the low pressure and the height to help them fly. So the plane could have been flying longer than it needed to. Center of gravity in real life is used in planes and other things. In Alaska, bush planes have center of gravities that are farther back from their nose that could keep their propeller up off the ground when they're landing in terrain that could cause damage to the propeller. Also, when planes need to refuel in flight and can't land, there's a plane that has 4 tanks of fuel spread out through their fuselage and their wings to control their weight and keep their center of gravity balanced in the middle. So when the plane is offloading fuel to the plane while in flight, it has to keep the center of gravity in the middle so it doesn't tilt left to right or forward. So the plane must take fuel from all the 4 tanks evenly to keep the center of gravity in the middle. If the plane was to take gas from the left wing, the center of gravity would change to the right because that's where all the weight is concentrated. Thank you for listening to my experiment. Any questions?
Yes. Thank you. Okay.